Page 81, we're going to look at solving one-step equations. One thing they talk about on this page is equivalent equations. So equivalent equations are equations that have the same solution or solutions. So what we can do is simplify things, and then we can see whether they're equivalent or not. If you look at the take note box, talks about addition and subtraction properties of equality. Basically, addition property says if you have an equation and you add the same number to both sides of the equation, you're going to get an equivalent equation. Okay, kind of like a balance. If you have a two-pan balance, if it's equal, if it's balanced, and then you add the same amount on both sides, then it's still going to be balanced. Same thing, subtraction property. If we take away, we have something that's equal. We take away the same from both sides, it's still going to be equal. Okay, and we've done that before. You know, opposite operation, they're subtracting, we add, they're adding, we subtract in order to get our variable by itself. So our goal when we are solving an equation is to isolate the variable. Isolate the variable means we're going to get the variable by itself. Another thing the book talks about here is an inverse operation. Inverse operation, same as opposite operation. So I'm usually going to call it the opposite operation. And that's what we have to do in order to isolate the variable. We do the opposite operation. So if you look at problem 1, they're wanting us to find the solution to this equation. Over with the variable, they are adding 13. So we're going to do the opposite operation, which would be subtract 13. If we subtract 13, we're going to isolate our variable. We'll get it by itself. The book shows this a little bit differently than what we're going to do. Rather than rewriting the whole thing again, we'll just go underneath there. We'll put minus 13 on both sides, and then we'll get our answer, x equals 14. What I really like about solving equations is that we can check our answer even if it's not in the back of the book. All we can do is just substitute our answer back in the original equation, see if it works. If it works, we know we got the right answer. So here we substitute a 14 in place of the x. 27 equals 27. We know we have the right answer for this problem. So if we look at the got it 1a, they want us to find the solution for this equation. Now they've made it a little bit more challenging by putting a negative number in there, but I think we're up to the challenge for that. So this problem over with the y that we're trying to get by itself, they're adding 2. So we're going to do the opposite operation, and we're going to subtract 2. When we go to do that, I know you guys have done this before, but you may want to just write that off to the side. Remember, for subtracting integers, we've talked about adding the opposite. So it becomes negative 6 plus negative 2, which would be negative 8. And again, if we have a few seconds, we could put that back in the equation and double check our answer. So we look at problem 2. Similar idea. This one is they are subtracting with the variable. We need to add. One other thing about this that I wanted to mention is some people do not like to have the variable on the right side of the equation. It shouldn't really matter, but if it bothers you, if these things are equal, if we switch sides, they should still be equal, right? Like if I'm weighing two things, they weigh the same. We switch the pans that they're in, they're still going to be equal to each other. So in other words, if you keep the order here, b minus 3, you could say b minus 3 equals negative 7 if that bothers you. Now, I understand we're going to be getting into some stuff later on where the variable is going to be on both sides. And so you can't always just have it on the left side of the equation. But anyway, this time then they're subtracting 3, so we can add 3 on both sides in order to get our answer. So we're going to look at a couple problems here on the got it. So on part A, they are subtracting 8. And so we're going to add 8 on both sides. So you add those together is -6. M equals -6. When you guys do these also, if you can, I just kind of use the line as part of a box and just box in my answer or circle your answer or something. And again, you need to make sure you're showing the steps of what you're doing to get your answers. So on part B, they're subtracting 3/2 from the side with the variable. We need to add 3/2. We add those together. 1/2 plus 3/2 gives us 4/2. And if we have 4/2, we can make 2 wholes. So answer would be y equals 2. Page 83. We've got 2 more properties of equality. First one, the multiplication property of equality says if we multiply by the same number on both sides of the equation, we'll get an equivalent equation. So they give an example there off to the side. Variable is being divided by 3, they multiplied by 3. And the division property of equality, if we divide both sides by the same number, we'll get an equivalent equation. So this one, variable is being multiplied by 5, divided by 5 on both sides. And we'll get an equivalent equation and we'll figure out what our variable is equal to. So if you look at problem 3, what's the solution of that equation? We can see they're multiplying, so we need to divide by 4. Divide by 4, we get x equals 1 6/10. So if we look at the got at 3, so this problem, the variable is being multiplied by 15, so we could divide by 15 on both sides. When we go to do that, that's going to create a fraction for us, so then it's just a matter of making sure that we reduce our fraction down if we can. So we can actually reduce both of these by 5 and get 2/3. We can't reduce that down any further, so 2/3 would be our answer. And again, I'm not mentioning this on every problem, but all of these problems we could substitute our answer back into the equation and see if it works or not. Part B. This problem, they are multiplying, so we need to divide by -3 2/10. One thing when we do that we should notice is that we're doing a positive divided by a negative, which is going to give us a negative answer. If we have time, we could do this by hand. Remember, you can't have a decimal on the outside when you're dividing. So it becomes like 140 divided by 32. So 4 and 12 over 32, we can reduce both of those by 4, and that would be 4 3/8. And then just remember, it is going to be negative, so -4 3/8. If you did that on your calculator and divided it out, you're going to get -4 375 thousandths, -4.375. And again, it's just a matter of whether you're allowed to use your calculator or not. You guys should be okay either way, whether you can use it or can't. Either way, you should be able to get that. Problem 4. The variable is being divided by 4, and so we need to multiply by 4 on both sides to get our answer. So if we look at the got it 4, part A, so variables being divided by 3 on the first part here, so we need to multiply by 3 on both sides to get that to cancel. So our answer would be 57, and again, we substituted in 57 divided by 3, we get 19. Part B is going to be a similar story. So this one, they're dividing by -9. We need to multiply by -9, which would be -72. If you look on the next page, it says when the coefficient of the variable in an equation is a fraction, you can use the reciprocal of the fraction to solve the equation. You have two options here. This is one option, okay? So what the book's doing on problem 5, our definition of reciprocals are two numbers whose product is 1. We always just did that with dividing fractions, right? So keep, change, reciprocal. That was the only thing. So we just flipped the fraction. That was the reciprocal. But the definition was two numbers whose product is 1. The reason that can help us in this situation is if we're solving, in this case, for m, 1m, those are the same as each other. So if I can multiply by something that gives me a 1m, I've solved the equation. So an option here is we have 4/5 m. We can multiply by 5/4. If you multiply, you get 20/20, which is equal to 1. That's 1m, which is the same as m. So, or you can say you're multiplying, you can just reduce like factors there and get those to cancel out. Okay, so that's one option. The other option, we're kind of ingrained with this idea of doing the opposite operation. We've done that a lot. So another option that's really not a whole lot more work for you is you could say 4/5 is right next to the m, means they're multiplying. You could say they're multiplying by 4/5. I'm going to divide by 4/5. And you might think, well, this is weird. They multiplied and you're dividing and you're going to get the same answer. Well, we're dividing by 4/5. Keep, change, reciprocal. Now we're multiplying by 5/4. If you look, that was what they did in the book on problem 5. So this way, it's just a little bit more work maybe. But again, if that, just opposite operation idea sticks with you, it's really not that significant to just say they're multiplying and I'm going to divide in order to get my answer. So if we look at the got it 5, they want the solution of this equation. So I'm just going to go ahead and rewrite that. And again, you got two different ways that you can solve this equation. So one option, if we follow along with how the book did it, we could say we could multiply by the reciprocal. Reciprocal of 3/4 is 4/3. And then those factors will just cancel out, or you'll get 12/12 x, which is like 1x, which is the same as x. And then we get 48/3, and then divide that and we get 16. So that's one way. Like I said, more familiar maybe if you want. Otherwise you can say they're multiplying by 3/4. Let's divide by 3/4. And when you do that, remember, keep, change, reciprocal, and we'll end up getting the same thing. Part B asks if these equations are equivalent. Basically what we'd be doing is if we solve the variable, if we solve for the variable and we get 18, m equals 18, then they would be equivalent. So that one, if you want to, we'll just do the quick way here. If you want, we can multiply by the reciprocal. And we get 18. So m equals 18, m equals 18. That's, kind of when we simplify, when we solve those. Again, if we get the same answer, then they are equivalent. So the answer would be yes. Another option you could do is, since this first equation was m equals 18, you could just substitute an 18 in place of m and see if that works, if it equals 12 by doing that. Look at problem 6. Toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Toucans are about 24 inches long. What is the length of an average blue and yellow macaw? So what they did here is they kind of tried to work this into an equation. Length of toucan is 2/3 of length of a blue and yellow macaw. So if we have L represent the average length of a blue and yellow macaw, length of the toucan we know is 24 inches. Is means equals. Of means multiply, and then this length of the blue and yellow macaw is what we're trying to find. So they just translated that into an equation, and then at that point we can solve. If you want to do the reciprocal like the book, multiplied by 3/2 is fine. Otherwise you can divide by 2/3 on both sides. Keep change reciprocal. You'll end up multiplying by 3/2 anyway, and then you get 36 inches. So if we look at the guide at 6, online DVD rental company offers gift certificates you can use to purchase rental plans. You have gift certificates for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? Well, it doesn't even say we have to write an equation. I think you guys can get this. You just take 30 divided by 5 would be 6 months. If we wanted to come up with an equation, we could say like 5m, 5 times the number of months equals 30. They're multiplying, so we could divide by 5. Not really the same level of question as the example that we just did right before that. But so a lot of this is kind of reviewing stuff with you guys. Let's look at number 4 here on the lesson check. You have already read 117 pages of a book. You are 1/3 of the way through the book. Write and solve an equation to find the number of pages in the book. So one way of doing this is we could say if we're 1/3 of the way through the book, then we need to read 3 times that amount. So 117 times 3 equals P. Could be an equation. We could say let P represent the number of pages in the book. And then this one, the variable is actually already by itself, so we can just multiply those together, and we would get 351 pages. Another option you could do is that you've read 1/3 of the book, so 1/3 of the pages, and you've also read 117. So these are equivalent to each other. So 1/3 P equals 117, and then you could either do the reciprocal idea, or you could say that they're multiplying by 1/3. You could divide by 1/3, and you'll end up getting the same answer that way also.